Sai Ram everyone. Now let us try to just find out how much work we have did in whatever hours we have spent. So accordingly, in terms of problems, how many we have solved the problems? Yesterday, total 18. Okay. And number of formulae, how many are there? The questions you made, number maximum, or you didn't make? Questions you made. How many questions? There is the hero. चलो बताओ, दोनों में से कोई भी बताओ. Do you have NCERT book? NCERT book? Show it to me. How many number of pages we have worked? Just count it. I have asked you to count it. So I understand the basic there that you will be having the size of the letters, that also matters. Right? So I was just taking how much we have worked. It's a long way to go. Around 40 to 45% as per the NCERT, the syllabus will be covered. But I can say 60 to 55% of syllabus you have to still go through it. I can only one thing assure you that refraction at the curved surfaces which leads to the lens, they are having the similar type of work which we have already carried out in concave and convex mirrors. I have explained yesterday to you, concave mirrors and convex lenses will be behaving in the same manner. And your convex mirror and concave lenses will be behaving in the same manner. The formulae, if you remember the approach, that approach is to be picked up by you properly. The approach was containing the important things. I'll tell you, first what I have did, when you started making a table, do you remember the tabular form in which you have drawn the ray diagram? I have given you the list of all the formulae related to it. Correct? And after giving you the list of all the formulae, you have incorporated those formulae in the table and actually determined the positions there. Am I right or wrong? So that method should be adopted. Even in NCERT book, they don't use this method. They directly give you that this is the picture. If you are having the object at infinity, there will be the image found at this particular place. Object is between the infinity and center of curvature. Where will be the image present? All the direct information has been given to you. I have told you how to understand what will be the description of image on the basis of calculation. Right? So that part you should never forget. Even when you are using the lenses, you should follow the same part. Okay? Now, today in the first part, we will try to cover some part of prism. After the prism is over, if you feel, I would like to talk about all the chapters, where I will be able to tell you that syllabus of physics is very small. How big the syllabus is from your perspective? From your perspective? मैंने पहला स्टेटमेंट ऐसा बोल दिया है तो डेफिनेटली विल से स्मॉल. How many chapters are there? 28 chapters are there. Okay. Now, if you look at the 28 chapters to be prepared, it's a tough job. But there are 13 concepts. If you understand these 13 concepts very clearly, you will find that almost 90% of the syllabus is done. This is actually the basic of all the syllabus that you are looking at. The topics are also related to one another. If one topic is prepared, the another topic is almost prepared. Only the terminology slightly differs, but it is the same. So, how these are the chapters related to one another, about that 28 aspects, 28 chapters, different aspect, I would like to talk with you. As I have already told you that I have shared the link of almost all the lectures except one chapter, work, energy, power. So you can access that. There are around 480 videos, around 50 minutes to 1 hour timing. 480 videos. Now, in 480 videos, it's a great amount of content that you will be able to understand. Only the basic part remains the same, that you will be having problem solving to be taken as a task. I'm not worried about bio and chemistry more, because that you will be able to do it naturally. But on the side of physics, if you make a habit of solving 30 objectives per day from a book, from the internet, from anywhere, you will find that your scores are bound to get increased. Okay? Got my point? So we'll first start with the prism, and towards the end, we will be talking about all these particular terms. Right? So what do you mean by prism? Anyone who can tell me what do you mean by prism? Prism is a pyramid. Prism. I'm not able to hear you. अरे बुड्ढा हो गया हूँ यार. अच्छा, which displaces or which disperses the white light into the 7 colors, you are calling it as a prism. So probably it is told to you that if you are taking one prism and a white light is passed through it, then you are able to see that the white light splits up into the constituent color, that we are calling it as a prism. Am I right or not? But can you imagine that you are making a white light incident and no light is emerging out of it? Can you imagine about it? You are making a white light incident on a prism and no light is emerging out. Is it possible? Is it possible? How? So by total internal reflection it is possible. So in that particular case, how can you say that it will be splitting into the 7 constituent colors? Number one. Second, they have a common thing that you take one prism, make a white light pass through it, then it splits into the 7 colors, then you place another prism upside down, you are able to get a white light. No. You can get again a spectrum in a reverse order. Now these are the things that are not mentioned in NCERT even. They talk of simple relations, that sum of the angle of refractions R1 plus R2 is equal to the angle of prism. Refractive index is given by sine of A plus delta M by 2 divided by sine of A by 2. How that terms are coming, that are important factors, but nobody is bothered about it. These two expressions are there. They say that the minimum angle of deviation takes place when you are having I1 equal to I2. And if you look at the deviation graph, you will be able to see that at a I1 equal to I2, the deviation is turning out to be minimum. All this stuff is given there as a part of a content of prism, but few part are not discussed in a detail. As I told you that always it will not produce a white light. It may produce a spectrum in a reverse order. That is again important aspect for the prisms to be understood. So I'll again begin with the same question. What do you mean by prism? So one thing is clear, it may split up into the 7 constituent color, or it may suffer a total internal reflection and there will be no splitting. Have you got it? So I cannot define by the splitting of a white light into the constituent color the prism. So how would you define a prism? Anyone? No. Prisms are not diverging. They are splitting or they are dispersing it into the constituent color. You are again using the word dispersion of light. So what do you mean by dispersion of light? Would you say that the crowd got dispersed or crowd got splitted? After the program, the crowd got dispersed or splitted. So there must be some difference between the disperse and the split. Split is to be divided into the parts. Disperse is to be spreading around. There is no specific direction. So we are using the word dispersion there. And if you remember, we have already explained there that why the light is dispersed into the constituent colors. Do you remember that? We have talked about refractive index inversely proportional to the wavelength. Wavelength for the red light is maximum. So refractive index will be minimum. The red light will be suffering minimum deviation because the speed of the red light will be maximum. So it suffers minimum deviation. Violet light has a maximum speed, so it suffers, minimum speed, so it suffers the maximum deviation. Remembering this part we have discussed? Have I discussed or not? Not remembering. At some point we have discussed this particular point, why there is a dispersion that is taking place. So what exactly is a prism is an important aspect that we need to understand. So how will you draw a prism? What is your perception about it? Pyramids type on a two-dimensional page. On a two-dimensional page, you will be putting it in a form of a triangle. Am I right? So that is why we need to understand what exactly the prism stands for, and that is not explained. We have a shape which is called as a prism, that is a different part, but prism is extremely important for all of us to understand when to call it and when not to call it. So just mention what is prism here. Mention prism. Prism is a transparent medium bounded by any number of surfaces. Bounded by any number of surfaces in such a way that the surface on which the light is incident and the surface from which light emerges are plane and non-parallel. Are plane and non-parallel. Will you like to call this as a prism? Will you like to call this as a prism? What definition you have written? The light should enter from one surface. So obviously these are not the parallel sides. I can show here the ray of light incident along this direction. It is traveling from air to the denser medium. So it will be bending towards the normal here. As it is bending towards the normal, it will be traveling like this. Towards the normal it has bent. It has not traveled along a straight line here. It is bending a little bit towards the normal. At this particular point, it will be traveling from denser to the rarer again. So you will be able to see that the ray, instead of traveling here, will be traveling along this direction. Now just check it out whether the definition written by you agrees with this part or not. Just check it out. Am I right? Does it agree? Does it agree? What does it say? It says that it's a transparent medium bounded by any number of surfaces. So here we are having any number of surfaces, 4, right? In such a way that surface on which the light is incident and the surface from which the light emerges are plane. Are those surfaces plane here? from which the light, from where the light is incident and from where it is emerging out? They are plane and they are parallel or non-parallel. So can I say that this is a prism? Can I say that this is a prism? So the perception that was built with us that it should only be a triangular in shape is not that correct. Getting it? I can even call this as a prism. You can check it out. Suppose I am having here a rectangle. And I am making a ray of light incident along this direction. Then I draw a normal to this particular point. This is your angle of incidence. It is traveling from air to the denser medium or rarer medium to the denser medium. It will bend towards the normal. At this particular point, it will be traveling along a straight line here. So it will be bending away from the normal. Can I call this rectangular parallelopipe structure as a prism? Getting it? Any shape you can consider, you should have non-parallel surfaces, plane surfaces from which the rays are getting refracted twice. Able to get it? Consider this situation here that we are having a ray of light incident along this direction. The ray of light is incident along this direction. This is representing a normal drawn here. Again, this is your angle of incidence. The ray, instead of traveling along a straight line, it is bending towards the normal here. And from here, you will be able to see that the ray is traveling along this direction again. Now, yes. So you are able to see that the two refracting surfaces are plane but parallel. So will you call it as a prism? So under what condition you will call it as a prism? If two refracting surfaces are non-parallel and plane, then you will be calling it as a prism. Able to get it? I can have one more structure here where I will be able to show it to you like this. The ray of light is incident along this direction. This is representing the normal drawn. Angle of incidence is here. Rarer to the denser medium it is traveling. So it is, instead of traveling along a straight line here, it bends and travels to this particular direction. At this particular point, if you draw the perpendicular here, you will be able to see that it is traveling from denser to the rarer. So it will be traveling along this direction. Will you call this as a prism? Are the refracting surfaces parallel to one another in this case? So can I call it as a prism? Now the normal prism which you draw will be appearing to you like this. In 2 dimension, it will appear to you like this. So for this prism, the ray of light is traveling from rarer to the denser medium. At this point, this will be called as angle of incidence. It will be bending towards the normal and then it will be bending away from the normal. So if you are calling A, B and C, which are the two refracting surfaces? AB and AC are the refracting surfaces here. So are the AB and AC refracting surfaces plane surfaces? Are they the plane? So can I say that they are representing to us non-parallel BA, plane BA, so it will be representing by definition the prism. Able to get this clearly? Right? So this is how we are able to define the prism here, what exactly the prism is all about. Any question, any doubt about it? Is it more clear now? Sure? Okay. Now you are aware of the fact that there are 3 types of prisms. Are you aware or not? How many types of triangles are there? Normally we have equilateral triangle, isosceles triangle, scalene triangle. तो जितने तरह के ट्राइंगल बनेंगे उतने तरह के प्रिज्म भी बनेंगे, right? So how many types of prism will be there? So 3. So we put it down in this manner. There are equilateral prism, right-angled isosceles, right-angled isosceles, or right-angled prism. Now here is an important point. Note it down. Angle of prism. So can you tell me which will be the angle of prism? एंगल ऑफ प्रिज्म किसे कहेंगे? A. So symbol A, you are looking at angle of prism. Why you would like to call the angle of prism? Suppose that prism is an equilateral prism. Angle A will be equal to angle B equal to angle C. So it will be equal to 60 degree. Why would you like to say A as an angle of prism? Why cannot I say angle B as an angle of prism? Why cannot I say the angle C as an angle of prism? Because all the three angles are equal. So angle of prism is 60 degree. Which angle you would like to call it as angle of prism? Are you getting me? Which angle would you like to call it as angle of prism? Where refractions are taking place, that will be contributing to the angle of prism. You cannot consider in this particular case B and C as the angle of prism, because angle B is the part of AB face as well as BC face. But does BC face contribute to the refraction? Does BC face contribute to the refraction? There is no refraction at the BC face, and therefore this B cannot be treated as the angle of prism. Whereas C, with the same reason, cannot be treated as the angle of prism. Whereas you look at angle A, you will find that angle A is the angle between the AB and AC. AB and AC are the refracting surfaces, and therefore the angle subtended by the refracting surfaces, you are calling it as an angle of prism. Now, I want you to find out a ray diagram, or to draw a ray diagram where angle B will be the angle of prism. Angle B will be the angle of prism. I explained to you how it is there, but you should draw the figure in the same orientation. Don't change the orientation. I mean to say, you will draw the same figure, displace B to this position, A to this position, C to this position. That is not the way. In the same orientation. So the ray should be incident on a BC. So if I show here the ray incident on the BC like this, this is representing the angle of incidence. The ray should have traveled along a straight line. but it is traveling from rarer to the denser medium, so it will be bending towards the normal. And here it will be bending away from the normal. For this particular pink colored rays drawn, angle of prism will be angle B. Draw the ray diagram such that angle C is the angle of prism. हो गया? So are you clear with the concept? What is angle of prism? Clear with it? Write down the definition of it, angle of prism. Angle of prism or a refracting angle of a prism means angle between the faces, angle between the faces on which light is incident, the light is incident, and from which it emerges, So normally we take only the equilateral triangles. This is representing to us the incident ray. If I draw the normal should be perpendicular to the face AB. Then this is representing to me angle of incidence I1. Then the ray, instead of traveling along a straight line here, it will be bending towards the normal. So it will be shown in this manner. This angle of refracted ray onto this side is known as angle of refraction R1. And then at this point again, I will be able to drop a perpendicular. The ray is traveling from denser to the rarer. So instead of traveling along a straight line, it is bending away from the normal. This angle here is called as angle of emergence I2. I2 is called angle of emergence. This is angle of refraction incidence. So you can join here these lines. This is the angle of incidence, which we are writing it as R2. You can mention below it that you will be having R1 is the angle of refraction, R2 is the angle of incidence on face AC. This is on face, or at, I should put it down, at face AB. Now, what will be the angle at the bottom here? Suppose I call this as ABC. I'm calling this as the point D. This point is E and this point is F. What will be the angle at the point D? Sure. Sure. 60? We don't know. It will depend upon the geometrical condition. So I cannot say that it will be how much value. But I can have here some angle marked as theta. Another interesting question comes up here. Can I say R2 as the angle of refraction? Can I say R2 as the angle of refraction? It's very easy to say yes and no. You have to provide the reason for it. Both are represented by R and R stand for refraction, so it can be represented. R1 and R2 are not equal. In case of parallel surfaces, you take R1 and R2 equal. Yesterday, when we were discussing, they were the parallel surfaces. So, one angle of refraction was equal to the angle of incidence. Because the surfaces were parallel. Here, the surfaces are not parallel. So, I cannot use that logic there. I2 can be? R2, I am talking of R2. Talk about R2 first. It is moving from one plane to the other, no doubt about it. Can I call R2 as angle of refraction? Can I call R2 as the angle of refraction? Why? Now look, according to the figure, R2 has been marked there as the angle of incidence on the face AC. It's angle of incidence only. I am asking you, can I call it as angle of refraction? Because I have denoted by R2, can I call it as angle of refraction? Yes or no? No. Not knowing? I can call it R2 as angle of refraction by principle of reversibility. Now that is why we have started working with it. You should have told me the answer first then. Do you remember now how we are connecting that principle of reversibility to this situation? If I reverse the path of the incident ray, then it will suffer the same path and it will be retracing the path in that direction. Under that situation, R2 would become angle of refraction, R1 would become angle of incidence. So in a way, I can say R1 and R2 are the angle of refraction. Getting the logic? Are you getting the logic here? Now, once you have done with this, you can put down some relations there. In triangle EDF, can I write down here R1 plus R2 plus theta is equal to 180 degree? Can I write down here? Similarly, in a quadrilateral AEDF, can I write down here AEDF? You will be able to have, okay. So what is angle E here? Angle E. So angle E will be 90 degree here. Are you able to get this angle AED? That will be 90 degree because it is along the normal. Similarly, AFD, this is also equal to 90 degree. Am I right? So can I put it down here that angle E, I am starting with angle E, 90 plus A plus 90 plus angle theta is equal to 360 degree. Can I put it down like this? Boliye ha na. So if we are able to put down this, 90 and 90 is getting cancelled. I just add it to 180. This is producing here 180 degree. So I will be having A plus theta is equal to 180 degree. That is my equation 2. So I can rewrite here R1 plus R2 plus theta is equal to A plus theta. The factor theta is getting cancelled and I am able to write down angle of a prism is the sum of angle of refraction at the two faces of the prism. This is my first equation today. Now there are small important things that you should take care of. You should always show the ray of diagram, in a ray diagram, the light to be incident in the lower part, not on the upper part. If you are shown the ray of light to be incident on the upper part, the figure of triangles would appear to you very small. इसलिए नीचे के साइड पे आपको वो ray diagram निकालना चाहिए so that it appears properly to you. Angle of prism is the sum of angle of refraction at the two faces. So what I did, I first proved that R2 is also known as angle of refraction because if I use the principle of reversibility, R2 would become the angle of refraction. Okay? So we are able to put down the relation. Now, isn't it surprising that we are having angle of prism a constant or a variable? Variable. Prism बनने के बाद जो आपका angle रहेगा, वो बदलते रहेगा. ऐसा कैसा prism बनाया आपने? A will be remaining constant. So what does that mean? If I change the angle of incidence, will the angle of refraction be changing or will it be remaining constant? If I change the angle of incidence, will the angle of refraction be changing at a one face or not? It will be changing. If that changes, the angle of incidence on the other face will change. If that changes, the angle of emergence will change. But the sum of angle of refraction at the two surfaces will be always equal to the angle of prism. Isn't it something surprising? It means that if R1 increases, R2 will decrease, so that R1 plus R2 will be always equal to A. R1 decreases, R2 will increase, so that you are able to see that R1 plus R2 is always equal to A because angle of prism is not going to change. Are you getting what I am trying to tell you? We have proved the relation R1 plus R2 is equal to A. This is our first relation today. But in this case, the outcome is what? Suppose I want to change the angle. Suppose I am now making here, I am drawing with a different color so that you can understand the difference. Suppose at the same point, if I am making the ray incident along this direction, has angle of incidence increased or decreased? Angle of incidence increased or decreased? You should have been a student like me and asked me such question. Has the angle of incidence increased or decreased? Decreased. Rest of the work is done by the teacher only. They will ask you, how it will increase? I said decreased. And if they say that, how it will decrease? I said increased. So up or down is extremely important. Is angle of incidence up or down in this case? Blue ray. Angle of incidence is always measured with respect to the normal. At the point normal is remaining same. पहले इसमें यहां से यहां तक एंगल ऑफ इंसिडेंस था, अब यहां से यहां तक है, और अब बोल रहे हो आप एंगल ऑफ इंसिडेंस हैव इंक्रीज्ड और डिक्रीज्ड? इंक्रीज्ड। कैसे इंक्रीज होगा भाई? इसलिए मैंने कहा अप और डाउन में बात करो. So angle increase, angle up or angle down? Now actually you are thinking this angle is above that of red. That is why it is up. I am asking about the upward or downward. So here angle has decreased. As angle of incidence has decreased, the ray will be bending towards the normal. So you will be able to show here, this will be the way the ray will be bending. At this point, if you draw the normal, the ray should have appeared to you traveling here. It will be now traveling along this direction. Now you check with this angle of refraction R2. Right? This with R1. What you are able to see, R1 has decreased, but as compared to this R2 has increased, so that the sum of the two remains always equal to the angle of prism. Are you getting it? So angle of refraction R1 or R2 may increase, may decrease. One is increasing, another one will be decreasing. If you make it more angle incident from here, if you draw this angle of incidence like this, you will find that R1 will be increasing, R2 will be decreasing. समझ में आ रहा है how it works? Getting it? Okay. Now I am again considering an equilateral prism. The ray of light is incident on the face AB. At the AB, you will be drawing the normal here. This is representing to us angle of incidence I1. The ray, instead of traveling along a straight line here, this is the original path of the ray of light here. Instead of traveling along a straight line path here, it will be bending towards the normal. It is bending towards the normal. This is known as angle of refraction R1. Right? Then you will be able to draw the normal at this particular point. This is a normal that has been drawn here. The ray will be bending away from the normal. This angle, you are calling it as I2. That is angle of emergence. You call this side to be emergence. This is your angle of incidence. We can call it as angle of refraction by principle of reversibility. Okay. Now, in this particular case, the light travels in a straight line, so it appears to me that it is traveling along this direction. This is representing the original path of the ray of light. Original path. If prism would not have been there, the light would have traveled along a straight line in this manner. But by introducing the prism, this is the final path along which the ray is emerging out. So there is an angle of deviation that we are defining here as delta. Angle of deviation. Getting the figure up to this mark. Drawn it. Drawn up to this mark. Now, let me put it down. The points here, A, B, C is already there. I'll call this point as D, this point as E, this point as F. Let me call this as G. Okay. So from the figure, can you tell me what is angle GDE? Angle GDE. What will be the angle GDE? What will be the angle GDE? Can I say here that angle I is equal to angle GD? F तक लिया है मैंने. I can H, angle GDH. Can I say that this is angle I is equal to angle GDH? So can you tell me what will be GDE now? Yes? A minus I? Where is I? That is I1. So can I put it down that angle GDE is equal to I1 minus of R1? Think about it. Can I say that angle GDE is I1 minus R1? How many of you agree with me? Raise your hands. Okay. Those who don't agree, raise your hands. How you can be in between the two? In Hindi we say that na ghar ka na ghat ka. Come on, at least you should agree or disagree. You are not ready to disagree also. You are not ready to agree also. And you say, yes, you tell, we will listen. That's only our job. So as some minutes have been spent, can again I ask you the same question? How many of you agree? Now under pressure you are agreeing. Chalo, who is going to explain this? Explain from your place. I'm not giving a mic to you. Now, there may be one problem. Let me solve that first, then I'll come to you. Probably from a long distance, you are unable to see. So you can magnify the picture on your copy, where you can see here that this is the horizontal line, a dotted line that has been drawn, which is representing a normal. And here you are having this as the ray shown here. This is your angle of incidence I. And then you are showing the ray traveling along this direction, so that this is becoming your angle of refraction R1. The original path would have been taken along a straight line here. So what will be this angle? These are opposite angles, so this total angle will be I. So what will be this angle then? वही तो मैंने बताया और आप बोल रहे नहीं 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 वो ये इसमें समझ में आता है पर इसको यहां पर रख दो तो नहीं नहीं समझ में नहीं. This is out of syllabus. This is in the syllabus. So how many of you understood? अभी सबके हाथ ऊपर है. Magic, na? Did I do anything else? Nothing. I have just redrawn the same part here. छोटे में दिखता नहीं है. Eyes बड़े कर दो. That is the only way you can go for it. So I think you are getting it now. So I am able to write down angle GDE is equal to I1 minus R1. So can I write down here angle GEH? Angle GEH is equal to I2 minus R2. Angle GEH is equal to I2 minus R2. GED. This is GED. GED. This is the angle I am looking at. I2 minus R2. Sure? Same logic. Whatever we have applied it on the face AB, we are applying the same to the face AC. Okay? Now, can I write down directly this relation that delta will be equal to I1 minus of R1 plus I2 minus of R2? So delta here would be taken as I1 plus I2 minus of R1 plus R2. Only nodding the heads. Sure, have you understood it? Pakka? So 10 pass ho ya fail ho? Because you carry the certificate. Board certificate you carry, therefore you are saying that you have passed it. So I am using some data earlier to the 10th standard or related to the 10th standard. Sum of the interior angle is equal to the exterior angle. I am using that particular part. I am able to write down delta is equal to I1 minus R1 plus I2 minus of R2. Got this? So can I put it down this relation as delta is equal to I1 plus I2 minus of A? Can I write down like this? Because we have already proved that R1 plus R2 is equal to A. So can I write down in this manner? So your angle of deviation depends on sum of the angle of incidence, because angle of refraction, angle of prism or refracting angle of the prism will be remaining constant only. For a given prism, angle A being a constant, your angle of deviation will depend upon the sum of angle of incidence and the angle of emergence. I1 is standing for angle of incidence, I2 is standing for angle of emergence. So on that factor it will be dependent. Sure. So if you decrease the angle of incidence, angle of deviation will be. Can you work on these lines? Because I1 plus I2 is an important factor. For a given prism, A is going to remain the constant. जैसे यहां पर करके देखा था हमने कि यहां पर ये I1 को डिक्रीज कर दिया था, I1 को डिक्रीज कर दिया था, तो ये ओरिजिनल पाथ आपका ये इस तरफ रहेगा, ये ओरिजिनल पाथ रहेगा, और यहां पर हम यही एंगल ले रहे हैं, तो ये एंगल वुड बी डिफरेंट. इट विल डिपेंड अपॉन I1 and I2 both. Actually, it depends on I1, it depends on I2, it depends on angle of prism also. But for a given angle of prism, if I am varying the I1 and I2, then angle of prism is not going to change. So in that case, delta will be more dependent on I1 and I2. Have you got this part? Clear yahan tak? Okay. Now, something here you should ask me. I am good that I am not your student, you are my student, because you are not asking any question. All teachers love to have such students which never have a question in understanding, whether they understand or they don't understand. If you would have been my teacher and you were teaching all this stuff to me, I would have raised the question to you. Angle of deviation cannot be equal to, is not equal to I2. No, mathematically speaking, it cannot be possible because you are having I1 plus I2 minus of A. Right? Now, if I am making here angle of incidence equal to 0, if under this situation, I am having a situation here, if I1 is equal to 0, delta would be taken as I2 minus of A. I1 is equal to 0 means you are making the light incident along the normal direction. Then it will be traveling along a straight line here. And from this edge, it will be bending away from the normal. So you will be able to see that this will be giving you the angle of deviation now, because this is the original path that you are looking at. This is the original path that you are looking at. This will be the angle of deviation. So in that case, angle of deviation would be given by I2 minus of A if angle of incidence is becoming equal to 0. Every lecture is related to one another. There is an interesting question here. Suppose you are taking a glass slab. And you are making a white light obliquely incident on it. Then you will be able to see that this angle of incidence will be there and the ray will be bending towards the normal. At this particular point, the ray should have traveled along this direction. It will be traveling along this direction. बराबर है? बराबर है या नहीं? In case of prism, a white light split into the constituent color. If I am making a white light incident on a glass slab, why doesn't it split into the constituent color? So what is the angle of prism here? What is the angle of prism here? Angle of prism. What do you mean by angle of prism? Angle between the two refracting surfaces. So what is the angle of prism here? It is not a prism because angle of prism is 0. But angle of prism is the angle between the two refracting surfaces. Are there two refracting surfaces? There are two refracting surfaces here. They are parallel. Prism will be called if they are non-parallel. Right? But what will be the angle? That angle will be 0. So in this case, angle of prism will be equal to 0. So if I consider angle of prism to be equal to 0, then delta will be turning out to be equal to I1 plus I2. But it is not a prism, so can I use this formula? That is how you have to think. कोई प्रिज्म दिया है जिसका एंगल ऑफ प्रिज्म 0 है, उसमें ये फॉर्मूला यूज ही नहीं होगा फिर. इट मस्ट हैव सर्टेन एंगल ऑफ प्रिज्म, देन ओनली यू कैन यूज दिस फॉर्मूला. ओके, तो यहां पर डिस्पर्शन होता क्यों नहीं है? बिकॉज एंगल ऑफ प्रिज्म इज टेकन एज इक्वल टू 0. सो मेंशन देयर, if the faces of a prism, if the faces of the prism on which the light is incident and from which it emerges or from which it emerges are parallel, then angle of prism will be 0. And as incident ray will emerge parallel to itself, deviation will also be 0. This we have already seen. This is the original path. You can compare that these two are parallel lines. This we have seen in a glass slab. So suppose you are having a light traveling through the liquid and the prism is made up of the same liquid. Then what would happen? Now, in the given situation for the prism, we are having always the light traveling from rarer to the denser medium, right? Or denser to the rarer medium. But suppose you are having a liquid and you are placing a prism made up of the same liquid in that liquid and you are making the light incident on the prism, then what would happen? What would happen? What would happen to the angle of deviation? What would happen? Angle of deviation in that case will turn out to be 0, right? Even if that is a prism, with the angle of prism, still angle of deviation will turn out to be 0 because the rays will not be changing the path as refractive index of the liquid through which the light is traveling and refractive index of the prism being the same. Got it? Mention that point. If mu of the material of the prism is equal to that of surrounding, no refraction at its faces, will take place. No refraction at its faces will take place, and light will pass through it undeviated.